Hello, welcome back. Today we're going to be talking about linear regression part 2. The objective is that you should be able to make predictions or estimates using the linear regression equation we found in part 1. To get us started, here's our first example. The following table shows the prices of used BMW X5s from Kelly's Blue Book in the DFW area and the year of the car. In other words, we have the year of the car and the cost in thousands of dollars for those BMWs. We're asked to find the type of correlation, write an equation of line of best fit, estimate the cost of a 2011 BMW, used one, and suppose that we have $55,000 to spend on an X5. About what year model should you be able to buy? Now, parts A and B should be a repeat from part 1. For extra practice, go ahead and pause the video, work out parts A and B, press play when you're ready to see the answer, and then I'll show you how to use the equation to answer parts C and D. When working out the problem, the very first thing we need to do is determine which variable is dependent and which variable is independent. Since the cost of the car should depend on the year, cost is Y, or L2, year is X, or L1. We're going to need to know that when we get our calculator and start typing in the data. So we turn a calculator on, we clear our RAM, second plus 712. We go to our stat edit and we start typing in the data. 2012. I went ahead and typed in the data into L1, L2. As a reminder, to plot the data, we go second stat plot, which is our second y equals. We press enter, and we press enter again to turn our first plot on so that we can plot the data. Then we go zoom, and we go zoom 9 for stat. Now you'll notice our scatter plot shows a very clearly positive trend, and that should make sense. The newer the vehicle, our x values, the more that vehicle costs, our y values. What's interesting is that BMWs, at least the ones that I chose from the Kelly Blue Book, the used vehicles in the DFW area, show a pretty linear trend as the cars get newer. So, what kind of correlation do we see? We see a positive correlation. Now, we're going to have to use our data to find an equation of the line of best fit. To do that, again, you go stat, calculate, linear regression. Press enter, and enter again. And we get our equation to be y equals 4.358x minus 8714.948. And that would be our equation. Let me go ahead and type that out for you. I went ahead and typed out the equation so we can use it to answer parts C and D. And I went ahead and also put in that our year was our independent, or X, and a cost in thousands of dollars was our dependent, or Y, because we're going to use that information to estimate the cost of a 2011 BMW X5. Well, since the year is X, we can use our equation to estimate the cost. We just put 2011 in for X. Again, because 2011 is the year. So we have our equation, y equals 4.358x. We have our x value. All we have to do now is type in, or rather substitute in, y is equal to 4.358 times x, 2011, minus 8714.948. Since on my screen recording software I cannot have writing and the calculator usage at the same time, I went ahead and typed that out for us so that I can show you how to enter that into your calculator. Now, we don't want to put y equals. All we want to find out is what y is equal to. So we're going to type out the right hand side of the equation. We're going to type out the 4.358 parentheses. Now the parentheses is above the 8, 2011. Now, we just got to substituting 2011 in for x, minus 8714.948. And hopefully 2011 will give us a reasonable value that lets us know our equation was fairly accurate. We press enter and we get 48.99. So, does that sound reasonable? Well, if we go to our table, 49,000 for a 2011 vehicle should be right around 2012, 2010 in between. We see that 49,000 is between 2011 and 2012, so that shows us our answer probably is pretty accurate. How much does it cost? We would say $48.99 or $48,990. And that would be our answer for part C. Now, part D is a little bit different. It says suppose you have $55,000 to spend on an X5. Well, $55,000 is how much we have to spend, and Y is the cost in thousands of dollars, so we know we can spend $55,000. That means we can put 55 in for Y. Notice I put 55 in for Y, not 55,000. That's because Y is the cost in thousands of dollars, and we have $55,000 to spend. So we have $55,000 to spend, and that should be equal to 4.358x minus 8714.948. All I did is I took the Y value, 55 for $55,000, and put it into Y in the original equation. Now we have to actually solve this equation. So to solve the equation, I'm going to add and this is where it gets a little ugly, where you're definitely going to want to use your calculator. I'm going to add $8,714.948 to both sides, plus 8714.948, and that's going to give us 5 plus 1 is 6, 5 plus 4 is 9.948, ran out of room there, is equal to 4.358x. Now we want to get x by itself, so we divide both sides by 4.358. Divide by 4.358, and hopefully we should get a reasonable answer when we take 8769.548 divided by 4.358 in our calculator. I went ahead and did that, and what I got was 2012.379. Now, since all of our answers are in whole number years, I'm going to round that to a 2012. Now, the reason for that again is it asks what year model should you be able to buy, and chances are you can't buy 2012.38 year. So we can buy a 2012 X5, should be able to. Again, looking at the equation and the answer, we notice a 2012 is about the best we could hope to buy. You might guess a little higher if it was like 0.8, but since it was 0.379, I went ahead and rounded to just 2012. Here's an example for you to try on your own. Please go ahead and press pause, work it out by yourself, and press play when you're ready to see the answer. Went ahead and enter the data. Again, to do that, we go stat edit after clearing the RAM, and we go stat plot, turn our stat plot on, and go zoom 9, and we see that it's a very clearly positive trend from left to right. Matter of fact, it's almost linear. What I forgot to mention real quick was that we always need to make sure we identify our dependent and independent variables. Since the height depends on the age, that means height is Y or L2, age is X or L1. So what type of correlation is shown? The type of correlation that we see from this graph is very clearly positive. Now what we're going to do with that data is we're going to write the equation of a best fitting line. To do that, again, you go stat, calculate, and linear regression. And I got an error. delete that x. Anytime you have something on your home screen that doesn't belong there, it's probably going to give you an error. So again, you go Stat, Calculate, and Linear Regression. Press Enter, and we get y is equal to 2.404x plus 30.624. So it says now estimate the average of a 5-year-old, average height of 5-year-olds. To do this, we would put 5 in for x, since our age was x and our height was y. So I put 5 in for x in our equation, and I went ahead and typed that in the calculator, the right hand side of the equation. Press enter, and I got 42.644. Now here's where you have to make a judgment call. The height, since all of the answers were in just one decimal place, that means when I write my answer, I'm probably going to write my answer in just one decimal place. So I'm going to go 42.6 inches. So the average 5-year-old, according to cdc.gov and our regression model we got from that, should be 42.5 inches tall, roughly. So on average, what age are 66-inch tall boys? To do that, again, since height is y, and we know that they're 66 inches tall, that's the height, again, height is y, we type in, or substitute in 66 for y, and we use the rest of the original equation. So there's our equation. We go ahead and solve that, and we get 66 minus 30. By the way, the minus button is right above the plus button. The button underneath the 3 is a negative button. That's when you want to make something have a negative sign. When we subtract, we use this minus button above the plus. So we go 66 minus 30.624. And we press enter, and we get 35.376. Is equal to 2.404 x. We're going to divide both sides by 2.404, and we'll get our final answer, 35.376 divided by 2.404 of 14.72. So what age are they? They're roughly 14.7 years old. Now we have to make a judgment call here. Do we answer in whole numbers or do we answer in decimals? Since all of our answers or initial ages we were given were whole numbers, we're going to go ahead and answer in a whole number. We're going to round that. 14.715. We're going to round that to about 15 years old. To be a little bit more accurate for this one, since it says on average what age, you could be a little bit more exact and say 14.715 years old. I would take either answer. I wanted to go ahead and show this. Divide by 2.404, divide by 2.404. And our final answer was 14.715 is equal to x. So there you go. You've made some predictions using an equation we found in our calculator.